Hello, today we're going to talk about misleading graphs, enhancement, distraction, and distortion. The first method we're going to talk about for making misleading graphs is scaling and axis manipulation. Among these items, one thing you can do is you can use an inaccurate scale, and another way you can do this is to remove part of the vertical axis. That means not starting the vertical axis at 0. Let's look at an example of this. Here's a chart that shows births to teenage mothers. If you look along the horizontal or x-axis, you can see the first year is 1990, and then 1995 and 2000, and then all of a sudden we jump to 2001, 2002, 2003. So when you start, you're going by 5s, and once you hit 2000, it switches to going by 1s. So that's an inaccurate scale. If you look on the vertical axis, you can see that it starts at 0.4 instead of starting at 0. So that's what they mean by removing part of the vertical axis. So another thing that's misleading about this chart is you can see that there's no units given on the vertical axis. So we don't know exactly what we're talking about when it says 0.9 what. To summarize, the distortions on this chart were inconsistent scale on the horizontal axis, no units given on the vertical axis, and the vertical axis starting at 0.4 instead of starting at 0. So these distortions make it look like the number of pregnancies have drastically decreased, but it may not actually be true. Here's a slightly less distorted view of this. You can see the horizontal axis is still not accurate, but the vertical axis shows a percentage change, so you know what you're looking at now, and also goes starting at 0. Method 2 is reversing the axis. So here is an example that shows the number of texts sent over several months. Generally speaking, you want time to move from left to right along the x-axis. If we switch these axes, as we do in this next slide, it actually looks, when you glance at this graph, that the number of texts sent has decreased instead of increased, that as it was shown in the original graph. Almost always, you don't want to put time on the vertical axis, and you never want it to be going down in time. Method 3 is using 3D charts. 3D charts are very hard to read, and you can manipulate them in Excel very, very easily. So let's look at an example of how you can manipulate 3D charts. Here's the data, grades on a test. 30% of the class got A's, 30% got B's, 25% got C's, and 15s didn't pass. The same data is going to be represented in the next 3 charts. With 3 different sort of slants on the data. Here's the first one. This is a sort of standard normal pie chart, and you can see pretty easily that A's and B's are equal, slightly less C's and even less no passes. Let's take this chart and manipulate it using a 3D viewer. Look how many A's I had in my class. What a great teacher I must be. So in Excel, you just grab the pie chart and you can move it up and down and left to right. When you spin those A's around to the front like that, it looks really big, like tons of A's compared to how many B's, C's, and no passes. But you can spin that graph around the other way to make it look that the no passes are really big. You all need to study so much harder. Look how many people didn't pass. In this graph, the no passes look about the same as the A's, B's, and C's, when in reality they're about half of those, each of those pieces. The last 2 methods I'm going to do in the same example. It's adding distractions and adding persuasive titles. Kids today don't study. This is another 3D graph, and you can see it's pretty hard to read. And there's a big giant arrow pointing down. Oh, look, that's what's going on today. This is a very inaccurate graph. It has no scale whatsoever. It's 3D, and it has distracting elements. So that's all I have about distractions and axis manipulations.